questions about anything we've covered up to this point? I'm going to do at least one or two, but do you have any specific questions? I'm going to make some comments too based on a discussion I had yesterday with a couple of students. And hopefully this makes sense. All right, when we talk about anything that has to do with the expected value of anything, so the expected value of any function, and I'll call it g of x, it doesn't matter what that is. What it always implies is an integration of that function times a probability density function over wherever the function exists. So it's always going to be an integral from minus infinity to infinity of g of x, dx in this case, but it's also, I should put density function, g of x times the probability density function, dx. And that's always going to be this, and usually it would be rendered as just g of x bar, something of that nature. Follow me? It doesn't matter what the function is. So when you have the mean values, if you have the expected value of some random variable x, that's going to be the integral from minus infinity to infinity of x times f of x dx. We've made that clear, and I think everybody understands that. Now that is the integral form. The analogous form that would be for discrete values, for instance, if you had possible outcomes of 1, 2, 3, 4, 5, like that power supply problem, whatever you want to call it, then you're going to have to do something where you're going to have now the expected value for the power right here is going to be, if it was an integral, you would have, I mean, a continuous function, you have an integral of p times the actual probability density function of p integrated over dp, all possible values. Follow me? And this, but for this case, if it's discrete, now you're going to have a summation. And here, I'm going to do this. I'm going to let p be equal to some p0 times k. It'll be easier to see it this way. And p0 is equal to 10 watts. And that problem was, I think, 2-4 point, is it 4 or 3? 4? 4. All right. This is actually a very telling problem. So here, first I have to take what's in here, the expected value. That's the first thing we're going to have. And I'll have p0 times k. Then after that, I have to have the density function. Now for this particular problem, how many did it, first of all, so I know who I'm talking to? Everybody should have, and it's an obvious problem if you think about it. Here we have discrete possibilities. We have 5 possible, is it a light bulb or what is it actually?
It's just a load. Yeah, it's
5 possible loads. Each of them has a probability of operating of 1/4 and they're independent. Then it says if they are operating, there's 10 watts. So the outcomes possible are none of them are operating. 1 of them is operating, 2 of them is operating, 3 of them, 4 of them, and 5 of them. Follow me? That's the possibilities, and they're all possible. To get the average value, you have to take, and this would be the power if one of them was on k, for any number of k, right? But now the actual functional form for the probability density would be the actual Bernoulli trial form. You would have a binomial coefficient. How many understand that? Y'all with me on this class? So here, now I'm going to go ahead and take it, and I'm going to say this is going to be n factorial over k factorial n minus k factorial. And here it's the probability of working, and I'll fill in these things in a second. The kth power times 1 minus the probability of it's working to the n minus k. And that sum here would be for k equals 0 to n. How many understand why I did what I did? Everybody got this, class? Now, the reason we're doing that, he didn't state explicitly the probability function, but he said all these things are equally likely and they're independent of one another. So it's like the coin toss. Think of it that way. You can have a coin come up heads or tails, called heads a 1, tails a 0. Think of it that way. Well, what's the probability of throwing it 5 times and having no heads? You would get it from that distribution. Y'all follow me on this, class? Same way with 1 head, 2 heads. So that's the density function that we're using. Now for this one, n is actually equal to 5. And that means you can put it in numbers here. And 5. And you can do that summing it exactly. But there's one thing, whenever you have n number of possible outcomes, and you want the mean value of that if they're equally likely and they're discrete, this will be, and I think I put this in the solution. As a matter of fact, I'm sure I did. This is going to actually be, and I'm going to take P0 out here, but what it'll be is simply the number of outcomes times the probability of the outcome occurring. Total number of outcomes. And it always works. If you think for that problem, there's n equals 5 possible outcomes, right? And the probability of working any one of them is 1/4. So 5 divided by 4 is 1.25. But you have to multiply that by P0, which is 10, because I factored that out. I didn't want to carry it through. Y'all with me, class? How many understand that? Now, the next part for this one is they want, I think, the variance, right? You can do the variance a couple ways. For the expected value of the variance, it's really the expected value of p squared. Well, not variance, sorry. For the variance, it's the expected value of p minus the average value of p, sorry, right here. And it would be that squared. And I'll say this, for this particular problem, because I'm not really sure with your calculators, which would be easier to do. But anytime you have something, you're talking about variance, expected value, and the mean squared value, I think it's easier for a lot of these with binomials to do the mean squared value first. Let me put this up here. You know that when you talk about the variance, this is the variance of, say, x, right? That right there is equal to the mean squared value minus the mean value squared. Everybody with me? So if they're asking, and I think they asked for the variance in this one, don't they? For the variance, I've already got this. I'm just going to get this. I could write the formula directly. You with me, class? But I'm going to do it that way. So for this one, what I'm really going to do is get the expected value of the power squared here minus the average value squared. That's what I'm going to do. And I think I put that in the in OneNote, that solution this way, didn't I? I don't remember how I put it in, but this is easier to do in your calculators. And I hope you all tried this one. So if you look at this, the expected value over here of p squared, now it's the same deal as we did here, only here we're going to put p naught k squared. Y'all follow me? So I'm going to just write that one time. So it's going to be a summation from k equals 0 to 5. This is going to be applied directly to that problem, times P0 times K squared. So I just put P0 squared, K squared here. And then it's going to be times 5 factorial over K factorial, 5 minus K factorial. Might as well put in the probability of this, so it's going to be probability it was on is 1/4, that would be a positive outcome to the k, and then it would be 3/4 to the 5 minus k. And you're gonna find that gets it every time. Are you with me, everyone? I mean, I think I made that clear. Now, I'm putting that up here in its entirety, so, you know, you'll see this, and how you program the calculator, I don't know, but there's one nice thing about this, and I think I put this in the solution, that there is a formula for this. Remember how I put, it's really, if you have n possible outcomes, discrete outcomes, each that are equally likely with a probability p, that the mean value of that process is np. By the way, that mean value doesn't have to be something that's observable. All these things, like think about that. Think about, for this one, the average value was, right here, I didn't put it down, it's going to be 12.5 watts. But that's not an observable value. The values you can observe are 0 watts, 10 watts, 20 watts, 30 watts, and so forth. So this is something, even though it never occurs, that is, you might say, the median value. It's the average value. It's the same with grading and stuff, for grades. The average value of the class may never occur. It just may not. And we'll talk about, there's things called, when you talk about the most likely outcome, then you look at the frequency. What is the score that the highest number of people got, the largest number of people. Anyway, for this one, and I'm not sure where this formula is in the book, but I don't know if I wrote it down here. Okay, let's see. There's a formula based on just N and P, you know, trying to find out where it is in this book. Matter of fact, I don't know if he shows one for the mean value in here either for the binomial. Maybe earlier on. Anyway. I know that one was 12.5 watts. What was the answer to this one?
Looks like 93.75 watts
That's
squared.
right. I put that formula in OneNote. Can you tell me what it is? I'm trying to remember, and I don't see it in the book. Do you know what I'm talking about?
It looks like it's the summation of P0 times K minus U, and then all that squared times
No, that's the
P.
actual, that's the definition of
The binomial.
this.
Oh.
I had a simple formula, and I think it's going to be it's going to be P naught times N squared, I think, times 1 minus P squared. But you know which formula I'm talking about? Anybody?
For the variance, you have NP times 1 minus P, and then you do
Okay.
the variance
Yeah.
W.
This is actually going to be, I think, P0 times N times P times 1 minus P. Is that right?
Yes, but it's P squared, P naught squared.
I'm sorry, you have to square this one too. Now, if you get rid of P naught squared here, if you just have a process with 0 through 5 outcomes, all equally likely with a probability of 1/4, following, or they're independent, with a probability of 1/4, then the actual value of the variance would be N times P times 1 minus P, and that's provable, where P is a probability of an outcome. If you look at that just for a second, think of ours. And make sure you kind of see this. Let N be 5. If the probability is 0 of it occurring, the variance is 0. If the probability goes to 1, it's 0 as well. Think about that. If it's going to occur or if it doesn't occur, there's no variance. I mean, that's the only possible outcome. There can't be any kind of, the variance is a measure of the spread in values about the mean. But that sort of gives you an idea of what this is about. This works, but you can always default to the calculator. And I want to say one other thing about this particular problem, because it implies you know how to get, it's the Bernoulli distribution with binomial coefficients, that you understand that from prior stuff. But if the probability density function for these was different, probability of the first one being on is 1/4, second one 1/2, third say 1/3 and stuff like this, then you would have to do the actual, the full form right here, what I have here, and this would now change. Do y'all follow me? And you need a mathematical way of representing whatever the probabilities are. I want to stress this because the questions I got made me think some of this wasn't as clear as I should have made it before. You good with this class? Something else, let's see here. All right, I have two things now I want to talk about. And a lot of times when they have word problems, it assumes you know how to create the probability density function based on what they say. Like this problem right here. So, if I say, I think this type of problem is in the notes, PowerPoint slides. I'm going to say this is a value of x, all right? And I'm going to say x between, say, 2 and 5 is equally like, so the density function here, f of x would be something you need to know. Let's say this is a value of a is the height. How do you always get that? What do you know about this particular function? Just tell me in your own words. If that's the probability density function, what's the one thing you know about it?
It's equally likely to be between 2 and anywhere between 2 and 5.
It is equal to 1 if you integrate from minus infinity to infinity of f of x dx. Do y'all follow me on this, class? It has to be. That's by definition, right? Now, if you take that and you think, well, for the problem I just said, that has a constant value, a, right? And then you can pull a out in front of there. Integrate dx, you get x. Evaluate between the upper and lower limit. Now, instead of going from minus infinity, we start at the lower limit, 2, right? Go to the upper limit, 5. So you get a times 5 minus 2. Or you can say a is equal to simply 1 over 3. That's how you would get it if it's equally likely to occur, or a uniform density. Everybody with me? Now, after that, for this problem, I don't think I gave you one like this, maybe I did. Now you've got the coefficient. Now the next thing I would ask for something like this is how you get the expected value of x. And just tell me what you do. It's literally just applying the math. Well, y'all agree it's going to be an integral, and it would go from what, 2 to 5, correct? Of, it's just going to be x times a. And since a is 1/3, divide by 3 dx. Do you agree? I know this seems too obvious, but I'm trying to make a real point, a point about this. Some of these problems are as obvious as that you think they are. You're just a little concerned it's too obvious or too easy. So this is going to be equal to 1/3, and then you're going to have 1/3 times, it's going to be x squared over 2, evaluated from 2 to 5. And that's going to be 1/6, and then you're going to have 5 squared minus 2 squared, or you're going to have 1/6, and it would be 25 minus 4, or you're going to have 21 over 6, and that would be the mean value. Do you agree? All right, now if I asked you to get the variance of this, or the standard deviation, how would you go about it?
Instead of x, it's x squared, right?
I would get the mean squared value first, because I think it's going to be easier. Because if you have, remember, if you have the variance, you'd have to take x minus the mean and square it. You're going to get 3 terms in that integration. Can everybody understand what I'm trying to say? Think about it. All right, you don't want that. You've already got the mean value. So the next thing I'm going to get is the expected value of x squared. And that's the integral, and this is as easy as it gets, in my opinion. It's going to go, the limits are from 2 to 5. Now I'm going to have x squared, right? And then times the density function, which is 1/3 dx. I think we all agree, correct, class? If you look at this, what is it going to be? Well, it's still going to be 1/3 integrate x squared dx. We get x cubed over 3. And then you evaluate from 2 to 5. So you get 1/9, right? And then you're going to go ahead and now you're going to get 5 cubed minus 2 cubed. And that's going to be 1/9 times 1/25 minus 8. I don't know what that is, but that's how you do it. Do you agree, everyone? Then to get the variance, you would go ahead and say the variance for this particular problem would be equal to x squared bar minus x bar squared. And for this case, I'm going to get 1/9 times 1. Let's see, you're going to have, yeah, 1/7. You have that minus, and the mean value on this is going to be 21 over 6 squared. I'm not sure what that is, but that would be the variance. Do you agree with that? One thing I got to tell you, the variance can never be negative. It can't. If you just think about this, the standard deviation has got to be positive. Even if it's negative, if you square that, you get a positive value. Do you follow me, class? It has to be positive, and that's something, it's just a check on this. I don't even know what that is, but that's one thing I can't do in my head.
It's 3/4.
Mm-hmm.
Is it 3/4? Something else about the variance. The variance is about the mean, so the mean value is 21/6 right here. And the variance tells you the spread here. It cannot be greater than the extent. In other words, this is 21/6, so if you think about it, this is about around 1/4. Follow me? I mean, sorry. I shouldn't say. If you think of 21/6, make it 24/6, all right? About 4. I'm sorry about that. So if you're from here, a spread to here is about 1, right? A spread to here would be 2. You can't have a variance greater than the maximum spread from the mean of the distribution, if you follow this. You couldn't have a variance of like 12. It would be impossible. But that's the kind of checks you do in your mind about things like this, because you can make mistakes. Okay. Got that part done. Oh, yeah. Couple other things real quick. I mean, these are things that should have been brought up from the problems and the lectures from before. I want to make sure I bring them up. Get the Gaussian. Everybody has their calculator here, right? I'm hoping. Okay. So something I mentioned last time is you can notice when there's odd and even integrations, and you can always exploit symmetry when you're evaluating the actual integrations. So if I have a problem, I'm really trying to drive this point home to you. And I don't mean to be insulting in any way, but suppose, just go with this. If I have a probability density function, f of x of x. Now, I'm going to show you, I'm going to draw something, but I'm not going to give you a mathematical representation. You're going to have to come up with it. Are you ready? You ready? So I'm going to have something that starts here from minus a and goes here to a, and that's the probability density function. With me? Now, I ask you to find a mathematical expression for f of x. Is everybody following me? There's one thing that you go for always, the integration of f of x over the possible values has to be 1, right? Integration. Well, you know this. I have a width of 2a, right? And the height of a, and it's a triangle. That means the area is going to be what? Just a times capital A. Do you all follow me? Everybody with me on this? Matter of fact, let me go ahead and, instead of making it small a and capital A, I'll give you hard numbers here to make it easy to see. Let this be minus 2 and plus 2, and you'll see why I'm doing it in a second. Go with me? Now if you look at that, A is going to be or times A is, I mean, think about this. It's the actual formula for area for that, right, would be equal to the base, which is 4, times the height, which is A, divided by 2. Do you agree with that, class? So A would be, the area has to be 1/2. Make sure. Do you agree with that? All right, so now, without me giving you a mathematical description, you know the height of this is 1/2. Now, everybody got me on this one. This is the problem. Sometimes people rush through this, they don't think through it, and they'll get A as 1. I promise you, they'll make dumb mistakes because they don't take time to think about what's being asked here. So now the next thing I'm going to ask is if that is the case, and I want the expected value of x. Just think about it for a second. Think of this like a prep for the quiz. Okay. All right, how do you get that? I mean, usually you're a little nervous on a quiz and stuff, so just write the expression. Well, it's technically equal to the integral from minus 2 to 2, right, of the function x, and I'm not even going to write the mathematical expression, yes, f of x dx. Isn't that it? But now, default to what I told you about odd and even. This function is
Even?
how many say it's even? It means the value of a positive value of x, f of x, is equal to the value of the f of minus x, whatever it is. It's symmetric. You can fold it You can literally take everything from 0 to infinity, fold the thing like a sheet of paper, and then overlay. It's an even function. But what is x? Odd or even?
An odd function.
Just think about it, right? This is x, right? The function x. F of x is equal to minus f of minus, right? So this is an odd function. Odd times even is
Odd.
odd. Odd integrated over from minus a to a is,
0.
how many see this? Are you with me, guys? You follow me or not? I mean, you can write the expression, but that's implicit, isn't it, class? So that means the expected value is 0 without ever doing the integration. That's my point here. I'm trying to save you some anguish, because you're going to get an expression for the functional form, then you're going to have to perform 2 integrations of the brute forces from minus 2 to 0 and from 0 to 2, and you're going to waste a lot of time when you can just look there. And as engineers, you always should be able to see the obvious outcomes. The things you don't need to work for, they're given to you. Now, how do we get the expected value of x squared? Well, go right to the formula. With me? So now I'm going to go from minus 2 to 2 of, now it's x squared times f of x. I didn't even put the expression in dx. Does everybody agree with that? Right? Okay, before we put the expression in for f of x, you'll notice that this is x squared is even, f of x is even, right? Multiply them together, you get even, right? If you have an even function, the integral, and you're integrating about something that goes from minus a to plus a, then the integration from minus a, in this case minus 2 to 0, is the same in magnitude as the integral from 0 to 2. Do you agree with that? So we only have to do one integration. I'll do the positive one and then double it. So I'll say that this itself is going to be the integral from 0 to 2 of x squared, and now I need an expression for f of x dx. So I'm integrating, and I got to put a 2 here, right? So now I need an expression for this line, right? I need an expression for f of x, and this is only for x greater than or equal to 0. How do you always get that? Well, do you agree with, in this case, this is a y equals mx plus b type problem? I'm going to see that. Right? All right. So the slope of this line would be minus 1. Slope would be the derivative of that line. How many see that? Got to make sure you do. You need to be able to write a mathematical expression for any simple types of functions. You have to. And you're going to find out when you take random signals and systems with Dr. Not random. When you take communications with Dr. Tugnay, he's going to require you to know how to do this. And he's also a stickler for trig identities and a few other things. I'll give you some tips about this later. All right, so for this, we know we've got an intercept, and I'll just put this. The intercept is a, and it's going to be minus, I should say, let me write it here. For this type of a function, f of x here is going to be some y equals mx plus b, right?
Mm-hmm.
So now you put in, you always look at the intersectional points. You look at when it's 0, and you look at where it intercepts here. So when x is 0, it has a value of a. Do you agree with that, class? So when x is 0, it has a value of a. All right, so a equals m times 0 plus b, or b is equal to a is equal to 1/2. Do we agree with that? Everybody? After that, you know it's equal to 0. This is 1/2. And here, the slope, it's going to be at x equals 2, so You got minus, give me a second, let me do that. I just write this down. Now I have y equals mx plus 1/2. Y x equals 2 equals 0 is equal to m times 2 plus 1/2. You agree with that? All right, so now I go over here and I put in the equation. That means that f of x is equal to minus 1/4 x plus 1/2. You can fuss with this any way you want. And you put that in here. And I'll put the 1/2 first, and then you're gonna have minus 1/4 x, and then dx. And that would get you the mean squared value. Do you all follow me on this, class? Now, I'm gonna warn you about these kind of problems. If you try to get the variance directly, here, if you wanted the variance, you would have x minus the mean value quantity squared. Follow me? The mean value is 0, so in this case, the variance and the mean squared value is going to be the same. They're the same. If the mean value is 0, they have to be the same. Think of the equation. With me? So just make sure you see that. And I'm trying to give you some tips about stuff that come up over and over again in this course, is evaluating integrations when you have to exploit symmetry. And you have to mathematically describe it. There's a lot of things you can get into. And I don't try to make this a course in describing a curve mathematically. But if it was something where, let me just tell you this one. Suppose it's this, from minus a to a, and it's a constant radius, a radius of a here. And this is my f of x. And this is x. I want to just talk about this. Now, what do you notice? Well, what's the area of a circle? Pi a squared, correct, class? If I have half a circle, the area is pi a squared over 2, agreed? So the area under here would be pi a squared over 2. Just remember that. Now, what about a description for this? If that's a circle, how would you do it? You remember that a squared plus, anytime you have a circle and you have a point that's offset, what do you have? You have x minus a quantity squared plus y minus b quantity squared is equal to the radius squared. Do you remember that, class? Where the a and b are the center points? Does anybody remember this? All right. This is a little, I'm not going to go there this time, but that's the type of thing you need to be aware of. So anytime, like, you have a circle, any kind of a circle, and if the center of the circle here is going to be some xy with a radius a, the equation for a circle is what? X squared plus y squared is equal to the radius squared, right? I mean, that's generally the equation. You can get y in terms of x, right? The nice thing about this particular one, I made the intersection here equal to 0, right? Correct, class? So you got x squared plus y squared equals a squared, or y itself would be what? For this equation, the equation that describes this circle right here would be f of x equals, and here, well, let me write it down first. You would have the radius a squared equals x squared plus y squared. Then you need a function of y, or f of x would be y. And for that, you're going to have a squared minus x squared, and then you're going to have a square root operator, but you'll have to have plus or minus. Can you follow me on this one? Let me see this right here. Now, you know one thing. From 0 on here, right? You're going to take this, right? It would be a positive. And from minus A to A here, it's positive as well. Do you agree, class? And if you have that, now you have a description of Fy from here to here, and you can get the value of A, you might say, because that's the area and that's 1, so you can have 2 over pi square root would be equal to A. Now this is a little more involved describing the actual f of x, but this is the kind of thing you should at least prepare for a test or on a final. Something like this. I'm not going to give you anything crazy, and I kind of always try to make sure I tell you how to do these things. Does everybody understand what I just said here? Any question about it? I'm not going to give you like an ellipse or something that's geometrically awkward to try to do, but you should be able to do triangles, straight lines, circles. Should have a mathematical description for those things because they're used all the time. And then we use cosine and sine for a lot of stuff too. Okay. Enough said of that. Now, next, I'm going to go to the next section. I want to tell you one thing. Even though I know your mind's on a quiz, please be attentive here. Do you have your calculators? All right. We're going into section 5, 2-5, and this is it's called a normal distribution or the Gaussian distribution. It is extremely widely used in almost everything that occurs in nature. The statistical way to describe things is based on a Gaussian curve. Almost everything. Or some actual form that's derived from Gaussian behavior. So it all is based on this. The probability that I'm going to draw it, then I'm going to actually give you the mathematical description. If this is x, and the mean value of x is here, the most likely, and this is going to be the probability density function. This is for a Gaussian curve, or a Gaussian distribution. Then, at that point, you're going to get a maximum value. And you're going to have something that looks like this. You've seen these kind of curves. They're called bell curves, normal curves, Gaussian curves. The actual way this is written, if f of x, if it is Gaussian, it'll have an expression that says 1 over the square root of 2 pi. You'll need to know this, but your calculators will allow you to do some of the calculations. So that's why I'm telling you to have your calculators available as I'm going through this. 1 over the square root of 2 pi, then times sigma. Now sigma is the standard deviation. Always is. Then you're going to have exp, and it's going to be to the minus quantity of x minus x bar squared over 2 sigma squared. Now that's the Gaussian density function. That's the probability density function. When you look at the cumulative distribution function, capital F, x of x, that's equal to the integral of this from minus infinity to x of 1 over the square root of 2 pi sigma, and then it's going to be times exp, and I'll put minus quantity x minus x bar squared over 2 sigma squared dx. But I'm going to tell you one thing. Technically, I should prime the value of x here because you can't end up with a kernel of integration, have an operation where you're going to integrate over that has the same symbol as the limit. You can't, legally, mathematically, but we're engineers, we know what we mean. With me, class? Now this can't be evaluated in a closed form. There's no closed form solution for that. So everything's done numerically, and there's approximations. They have tables in the book. If you look at the actual PDF of the book, y'all have that, right? If you look at the PDF of the book, and you go to section 2-5, and you keep going, I don't think I have time to get this right now, I can put it up. You're gonna see tables of something called the normal, or the normalized distribution for this stuff, but your calculators, I'm gonna tell you one thing about your calculators. They do this stuff and they do it brilliantly. So, this would be the cumulative distribution function. The way the tables are built is this. They have a function, and they're going to use the symbol phi, and really it should, I'll call it phi of x, and this is something that uses normalization. I'll explain it in a second. So the definition of this thing is the integral from minus infinity to the value of x of 1 over the square root of 2 pi, gets rid of the sigma, and it's exp to the minus the quantity simply x squared over 2 dx. And I should prime those. Now you look at that and you'll notice what effectively happened is sigma became 1 and you got rid of the mean. Do you all follow me? Now this is a function in the book. If I'll give you a page number, if it has it here. It's in the back of the book for sure. There's a lot to be said about Gaussian distributions. I'm showing you this. It's on, if you write this down, page 69 in the PDF. And it's equation 2-17 and 2-18. Now, I'm going to show you something. If you look in the back of the book where the tables are, and the PDFs, the slides I put up, I actually took snippets from the tables. You aren't going to need these tables, though. I believe your calculators will do a much better job of it once you get used to them. And on page 432, they have tables of the normal probability distribution. So right there, just put that down. If you look there, this is on page 432, so it's at the very end of the PDF. But if you look at this right here, what this means, and now I'm going to say it explicitly, if I want the cumulative distribution function for x of x, what you can actually do is this. You can say it's the same as this, but instead of x, what you're going to do is put the argument as x minus the mean, and the mean value is really u usually, divided by sigma. Now what that is, it subtracts, it effectively does, you can call this x bar if you want, but u is the same thing as x bar. It will give you that. That's from the tables. Y'all have your calculators there, right? If you take a look on your calculator, they're going to have something that says normal distribution, or it's going to say Gaussian distribution, or bell curve, something like that, and you're going to see, y'all see it?
So it was going to be called like a what distribution?
What?
Oh, which ones you said? A what distribution?
It'll be either Gaussian or bell curve typically, or normal, N-O-R-M-A-L, one of the three. Can y'all see it?
I have one that's normal PDF and normal CDF.
Yeah, the probability density function is going to be the normal PDF. CDF is the cumulative distribution function, and that's this right here. Now, if you look, the real thing we care about is the cumulative distribution, right? So that tells you the probability of the event being from minus infinity to the point, the argument here. You all with me, class? Now, in your thing, Y'all have your calculators, right? I know you're probably not that attentive to this, but please try to be, because if you have a calculator, you don't know how to operate, chances are there's somebody here that does, and they can show you. If you look at that normal cumulative distribution, CDF, you're going to see that they have an input X. That's where they want the integral to end up at. Then they're going to have an input U. That, they want the mean of that. And after that, they're going to have an input sigma. Do you all see this, class? How many do? You do see it on yours? I mean, I want to make sure. Did you have a question?
No, I'll just.
Okay, you got it? All right, here's what I'm really telling you. You don't need to look at the tables. As a matter of fact, we're going to do something. For yours, would you take your calculators? I've learned this lesson the hard way. I'm going to forget about tables because it's a waste of time if you got a calculator, in my opinion. And that's how I feel about STEAM tables. Don't get me in trouble. I do not like wasting time on tables unless I absolutely have to. So I want you to take a look at yours, and this is going to be the cumulative distribution function. And just type in this. I want you to tell me what the value of this is. For x equals 0, mu equals 0, and sigma equals 1. Just tell me what that value is.
0.5.
I want everybody to take a look at that. You with me? Now, first I want to make sure everybody sees that. Still got a few people. Try it. Anybody not be able to get that with your thing? Everybody got it? All right, now do me one favor. For this one, change it. Can you put lower limit, upper limit, or not on yours?
You can do both.
Is there anybody that can't? All right, now do this. Take it and go from, for sigma equals 1, mean is 0. Find the cumulative or find the actual, would be the integration is find f of x of 1 minus f of x of minus 1. Tell me what that is. And I'll show you what you're doing. You're going one standard deviation across in either direction. So this is the area under this curve right here. I'll tell you a clever way to do it in a second. Would you get?
0.682.
That's correct. Anybody else? 68% in one standard deviation from the mean. Follow me, class? I made the mean 0 on purpose. Now, so from here to here, it's going to be 0.686 roughly. Is that about right?
6826.
6826, sorry. About 68% of the total area is within one standard deviation, close to 70. Now within 2 standard deviations, because I made the standard deviation one to make this as simple as possible. What do you get? It's going to be 90 something, 0.9.
Yeah, 0.954.
Confirm? You guys, let it get it. 0.954?
Mm-hmm.
All right. Now you hear about this. This is within 2 standard deviations of the mean on either side. That's almost the whole area. Within 3, what should it is? It's 99 point something. F of x of 3 minus f of x minus 3 equals
Oh yeah.
997.
what?
0.997.
All right. Almost 100%. There's only 3% outside. Let's see, well, actually, 0.3% outside that range. So when they talk about bell curves, normal curves, or Gaussian curves, and they say we're within 3 standard deviations, now I use this with targeting and radar. When you say you got the target locked within 3 standard deviations, you got the target. Because the likelihood it's outside of that range is, it's getting almost infinitesimally small. Follow me on this, class? It gives you a sense of the certainty. So this one has a mean of 0, it's got a spread here of 3 standard deviations of, if you look at that, from what? +3 to -3 is total width of 6. That's significant. A typical type of thing with targeting, and I'll just say this with radar, you're going to see this go way down, like 10 to the -2 and stuff like this. It's going to be like a needle point. And your mean may be higher or lower. In other words, you may find out that the density function, the probability of the target's somewhere on the horizontal plane moving, it may be skewed by like 5 units, whatever those units are. But the spread on that is going to be extremely small with a good radar. The poorer the radar, the larger the standard deviation. I'm trying to just give you something physical to think about when you're doing these kind of things. You good with this, class? I'm going to give you problems related to this, and we're going to talk about them next time. But right now it's quiz time, so how about we do this? We'll fill this row right here. Empty that row. Empty that row over there. So then we're going to fill this row